So let's do another example, just more practice with planes, more practice with some of the other resources that we have at our disposal. So let's see what we've got. Example 3. Okay, find a vector parallel to the line of intersection of the planes (3x minus 2y plus z equals 1 and 2x plus 2y minus 2z. Let me make my 2's and my z's a little bit different here. Is it minus? Yes, minus 2z equals 2. Okay, so we have two planes and they intersect. Two planes intersect in a line. So if they intersect in a line, we want to find a vector that is parallel to that vector. Okay, I'm sure there are a number of ways to do this. I mean, one of the nice things as you sort of move on into higher and higher mathematics is that there is a whole, plethora of ways that you can approach a problem as you, gain more tools at your disposal. What I'm going to do in this case is I'm just going to go ahead and choose two random points on that line, and then I'm just going to sort of take the vector that connects those 2 points. So it's parallel. It happens to actually be on the line, but it's certainly parallel to that line. So that's it. So that's what I'm going to do. So find 2 points on this line. We'll call them P and Q. Then take Q minus P or P minus Q. Again, the direction of the vector doesn't matter. Any vector is fine, whether it's one direction or the other direction. Parallel is this way and that way. Okay, we're going to end up actually solving 2 equations and 3 unknowns. So here's what I'm going to do. I'm going to actually choose, and again, this is a line, so there's an infinite number of points that I can choose from. What I'm going to do is I'm going to choose a z, and I'm going to solve for x and y. Then I'm going to do the same thing for another point. Choose a z, solve for x and y, and then those are going to be my 2 points P and Q, and then I'm going to take the vector in between them. Okay, so let's just start off. So we will let z equals 1. So when z equals 1, these equations become implies. So we have 3x minus 2y plus 1 equals 1, excuse me, and 2x plus 2y minus 2z, minus 2 times 1, minus 2, is equal to 2. So this equation becomes 3x minus 2y equals 0, and this equation becomes 2x plus 2y is equal to 4. So now I can go ahead and solve this. I end up with 5x is equal to 4. I get x equal to 4/5. And now when I put 4/5 back into here, let's just sort of choose this one, I get 3 times 4/5, which is 12/5, minus 2y equals 0. I get y equals 6/5. Okay, so my point P, my first point, is going to equal 4/5, 6/5, and 1. I don't want to deal with fractions, so again, any vector, any multiple of a vector is pretty much the same vector. It's in the same direction. So I'm going to go ahead and take P. I'm going to multiply everything by 5. So I'm going to use, so I can work with whole numbers. So this is going to be 4, this is going to be 6, and this is going to be 5. So 4, 6, 5 is my first point. Now I'll do the same thing with another point. I'll just choose another z and run the same process. Okay. So this time we will let z equal 2. Z equals 2. So this implies we get 3x minus 2y plus 2 equals 1. And we get 2x plus 2y minus 4 equals 2. So these equations become 3x minus 2y equals minus 1, and 2x plus 2y equals 6, I think. Yes. And when we add those, we get 5x equals 5. We get x equal to 1. So we put 1 back in here. Either equation is fine, so I'll just go ahead and put it in this equation. 2 times 1 plus 2y equals 6. 2y equals 4. So y equals 2. So now our point Q is equal to x is 1, y is 2, z is 2. So now I have Q is 1, 2, 2. Okay, so Q is 1, 2, 2, and from the previous page, we said that P is equal to 4, 6, and 5. Therefore, Q minus P, 1 minus 4 is negative 3, 2 minus 6 is negative 3, 2 minus 5 is, wait, 2 minus 6 is not negative 3, 2 minus 6 is negative 4. Can't even do my arithmetic. Negative 3, negative 4, and 2 minus 5 is, this is negative 3. So there you go. This is a vector that is parallel to the line, which is the intersection of those two planes. I simply chose 2 points on that line, and I took the vector. I can choose 3, 4, 3 if I want, just multiply by negative 1. It doesn't matter. Again, the direction doesn't matter. Infinite number of vectors to choose from. So that's it. Okay, thank you very much for joining us here at Educator.com and Multivariable Calculus. Next time we'll begin our discussion of differentiation of vectors. Take care. Bye-bye.